Okay, so we've got three different types of overlap events, and we've gone over the different ways that they work. Begin overlap being any component overlaps, then it gets fired. For example, basically the ball running into the sphere or the cube will both fire off this event. However, the component begin overlap is unique to an individual component and will only get fired when that specific component gets overlapped with something. So in this video, we're going to get into how to tell the difference between types of things that overlap with these collision volumes, and this ties into a concept of casting. Now, casting is when you take some sort of value and you check to see if it is a particular type. And this has to do with a concept of inheritance. And this is sort of if you're already a programmer, you'll understand this. But if you're not, then it'll be a new concept to you. But basically, remember that when we created my actor, we right-clicked and we clicked Blueprint Class, and you'll see that it says Pick Parent Class. And we say parent because when we choose something like actor, what we're doing is we're creating a new type of class that inherits from actor. And what it does is we say that it's an actor because it contains all of the functionality that a basic actor has, but it's a child of actor, and we say that it is an actor, but it's also more unique than an actor because the class that is known as actor does not have a cone in it. It does not have a box or a sphere. That's all unique to our class, our new class that we created and we named my actor. So my actor, it has the ability to create an event begin overlap event. It has the ability to print a string. This is all stuff that's inherited by actors, but it also has new unique things like our components that we gave to it. And so it's said that it is an actor, but more specifically, it's a my actor. And so in order to, in our code, tell the difference between just any old actor and a specific actor that is of the class my actor, we can cast. And so this will be more easily understood with a example. And so we're going to create a easy way to see exactly what I mean. So let's take our actor here, our my actor, and let's bring it in close to our ball because we're going to want to, as soon as we hit play, we're going to want to be able to see it without moving the ball over to it. And I'm going to take this template cube here, and I'm going to delete it, get it out of the way, and let's select our actor, our my actor, and bring it in here so that when we hit play, then we'll see the actor here. Okay, so we've got the actor here in front of our ball, and I'm going to go back into my actor, into the viewport, and let's do a couple things here, like let's take the cone and get it out from above this cube, and I'm going to move it over to the side here. I'm going to take the box, and you'll see that the box has a box extent here in the shape category. And this allows us to change the size of the box component itself. So this is different than scaling the actual root here, because if I take the scale and say change the X, Y, and Z all to 2, then because the sphere and the cone are children of our root component, they will be scaled as well. So I don't want to do that. Let's change those back to 1. And let's take this box extent here and change it. So instead of 32 in the X and Y, why don't we change these to about 64 in the X and Y, like that. We can leave the Z as it is. And now you'll see that the box is changed, but we haven't scaled the entire thing. We haven't scaled the root component. We've only changed the box extent. So now that we have the box a little bit bigger, a little wider, and we move the cone out of the way, let's go back into the world, and we'll see that we can see the box here, and if we hit play, we can still see it because show or hidden in game is no longer set to be active. And what I want to do is I want to take one of these boxes, one of these template cubes from the world, and I'm going to drag it over to where it's just above the box here. And what I'm going to do is, with this box actor selected, I'm going to come in here to the details panel, drag this section up, and I'm going to scroll down to where I see physics here. And you'll see that simulate physics is set to true. That's why we can bump into it and knock it around in the world. And you'll also see that enable gravity is set to true. And because enable gravity is set to true, as soon as we hit play, that box is going to fall down. So when the box falls down, it's going to collide with our overlap component. And you'll notice something that is very key here, and that's that because it falls down and collides and overlaps with the box, you would expect that these events here, event actor begin overlap and event component begin overlap for the box, you would expect these to both get fired and the print string be called, and you would see strings printed to the screen, but we don't see that. And the reason is because if we select our box, just under the physics, we can scroll down, and there's a collision section here. And you'll see it's a very thin line here, but we can actually drag it out so we can see these a little bit better. We can also get this entire section and drag it out so we can see this section and read these better. And you'll see that in the collision section, you'll see this generate overlap events. And you'll notice that it's not checked. Now, if we check it and then we hit play, you'll see that now when the box falls, the overlap events get fired off. And this is a very important setting to keep in mind whenever we create functionality for overlap events. Because for an overlap event to happen, the thing that's overlapping with it must have this set to true. This is basically a true or false value, and if it's unchecked, it's set to false. If it's checked, it's set to true. And if it's not checked, set to true to generate overlap events, then this box will never generate any overlap events. And as we saw with it not checked, nothing happens when it overlaps. So that's one important thing to know, is that in order for the box to participate in these overlap events, this needs to be set in the collision section for the box. So that's one thing. And now, as we were talking about casting and determining whether something is of a particular object type, what we want to do is, as soon as this box collides in the overlap events, we want to check to see if it's a particular type. Now, what we can do is in the event, let's do the event component begin overlap for the box. I'm going to drag this print string out a little bit. And if we scroll in, you'll see the node has some output values here. And you'll see that there's an output value for event actor begin overlap as well. And this is, it says other actor, and in the component begin overlap node, we also have an other actor. And what this is a reference to the actor that overlapped with it. So every time this gets fired off, it'll get fired off every time another actor overlaps with this actor. And then we have the opportunity to get that other actor, get a reference to it here. And actors are color-coded blue in Blueprints. So if you see an output value that's blue, if you hover over it, it's going to say actor object reference. And that's what we can use to access that other actor in code or in Blueprints. And so what I'm going to do is, on the event actor begin overlap, I'm going to drag off of this. And what I'm going to do is type cast. And you'll see that we get all these different options to cast to particular types. And what we can do is we can cast to, and we can type a particular type. And if we come in here and look at our ball and select it, you'll see that in the world outliner, it says physics ball BP. That's the name of this object. But if we right click on it and click browse to asset, then we'll be taken to the actual asset itself. And this is a blueprint for this particular ball. And you'll see that physics ball BP is the name of the blueprint. So if there were multiple objects in the world, they could be named different things like physics ball BP1, physics ball BP2, or you can even click on it and rename it in the world here and say the ball, for example. You can do that and rename it. But if you look at its blueprint, you'll see that the blueprint is called physics ball BP, and that is the type for this particular object, for this particular actor. So what we can do is we can check to see if other actor, which is of type actor, we can cast it to type physics ball BP. And so this does a couple of things. First, it checks it to see if it is that type. So if we drag off and type cast to physics, then we'll see cast to physics ball BP. If we select that, then we've got this node that will cast to physics ball BP. So it does a couple things. First, it will either succeed or fail depending on if it was a physics ball BP or not. So we can take this event actor begin overlap, we can drag its input execution pin in, and we have two different possibilities as far as execution wires go. We have one, the top one, and that's basically if it succeeded. So if the thing that collided actually is a physics ball BP, then this execution output pin will be fired off. And so we can, let's take this print string and let's change the string to say overlap with physics ball BP. So we have that in the case that the cast is successful. However, if this event gets fired off and the other actor is not a physics ball BP, for example, if it's simply a static mesh actor like this one, then the cast failed will be fired off. And we can actually drag off of this one and have some sort of alternate route in the logic. So if we type a print and select print string here, we can have another print string node. And in this one, we can say not a physics ball BP. And we can, just for, just to make it look different, let's take this text color and let's change it to a red. And that way we'll see that it looks different. So we can drag and select multiple boxes and move them up, because as these nodes get more numerous, you're going to want to keep these nice and organized. So this is one of the things that casting does, is it checks the type, and if that type is of the type we're casting to, then the cast will be successful and you can do something in that case. And if the cast is not successful, you will do something else. So let's go ahead and hit play. And you'll see that, and it's kind of hard because the click for mouse control is sort of in the way. So let's do it again. And you'll see that it says not a physics ball BP because our casted the other actor. It took that reference to it. It casted it to a physics ball BP, or at least attempted to do so, but the cast failed because the box is not a physics ball BP, it's a static mesh actor. And so we got this line of logic fired, but we did not get overlap with physics ball BP. What did happen was the overlap component begin overlap node printed overlap with box component. This fired because this one doesn't cast. It just, whenever an overlap happens, it prints the string. But what we did not get was the overlap with physics ball BP message printed to the screen. That did not happen because the cast failed. Now, if we go ahead and hit stop and we move the box over to the side and we hit play and we go ahead and start playing with our ball and we overlap the ball, now we get that message that says overlap with physics ball BP because the cast was successful. It took the other actor, and we're going to go back into the my actor here. It says other actor here. It took that value, that reference to the thing that overlapped. We casted it to physics ball BP, and because the other actor was a physics ball BP, then this execution wire gets called, and we get print string overlap with physics ball BP. and you know, I'd like to actually change this color to something like a yellow. That way we can sort of really get to see that that's the execution wire that gets called. And there it is. There's our yellow overlap with physics ball BP. We can overlap multiple times and it'll get called multiple times. And so that cast was successful. So that's one thing that casting does. And another thing it does is it gives us a reference to that other actor. And I know you're thinking, well, we already had the reference here in the form of other actor, but this is a different data type than this. This coming out of the event actor begin overlap is of type actor. And so it only has access to those functions inherited from the actor class. So, you know, things like print string and all that, that is accessible from this because those belong to the other actor class. But as physics ball BP, now we can access things unique to physics ball BP. And we're going to get more into, you know, the distinction between more specific data types as we go along. But just so you know, you can have a reference, and this reference is an actor, but it's also more specific. It's a physics ball BP, and that is more specific than just a regular actor class. So casting is a way to check a type and see if it is of a more specific type, and because we want to check to see if the thing overlapping is a physics ball BP, then we can check that and we can print one string or do some sort of logic in our code. In our case, we're just printing strings, but we could do other things too. But we could print one string if it's a physics ball BP. Otherwise, we can print a different string and we can say not a physics ball BP. And if we really wanted to, we can also cast in the event that the cast failed. We can also check to see if it's of type static mesh actor. For example, if we take other actor here and we drag off and we type cast to static mesh actor, now we have a cast to static mesh actor. If we drag this over and we hook up the output from print string here into it, now we're casting the other actor to a static mesh actor, and now we can print a different string. In this case, we can create a print string node, and now we can type static mesh actor overlap. And let's go ahead and make this one a different color, say green, and click OK there. And now if we go back and hit play, then actually instead of hitting play, let's take this box and move it above our collision volume again, hit play, and now you get the green. It says static mesh actor overlap, and so we can actually check to see if it's a static mesh actor as well. Now notice that these wires are getting a little unorderly, and so I'm going to show you a technique for organizing these wires because it's kind of hard to see which wire goes where. So if you take your mouse over a wire, it's highlighted. If you double click it, then you get what's called a reroute node, and this, you can move this around, and that way you can see that this execution or this other actor type data type node is going down here and actually going into this other cast node here. And you can add multiple reroute nodes, and that way you can keep things orderly. And so what I like to do is I like to take my nodes and make them sort of organized like this so that you can see exactly where each wire goes. So as these get more and more complex, I use reroute nodes so that you can see exactly where each one goes. And so this is a good way to basically determine if a data type is of a specific type. So if we have an actor, but we want to check to see if that actor is a physics ball BP, we can check, because as it stands, because the ball is an actor and the box is an actor, they're both actors, because anything that can be dragged in the world is an actor. Actors, though, can be more specialized and more specific, and for that reason we need to be able to determine between different types, and so that's where casting comes into play. So we can cast to physics ball BP, we can cast to static mesh actor, and we can have different lines of execution depending on whether those casts are successful or whether they fail. And so we could also do that in these other begin overlap nodes as well, because they have a reference to the other actor that overlapped with this component. So we can do casting in any of these. And of course, the begin overlap for the components have other output values, and we're going to get to what those do very shortly. But just for now, I want you to understand what casting is and that you can use it to tell the difference between actors in the world based on what's happening. So that's casting, and stay tuned. We'll get into more specific functionality in future videos.